Sanemonani, Dunelani, yes. Good people. Tab. Le résultat immédiat, c'est tout le monde a weekend. So weekend in the for those that were not clear, 1, 2, 3. I want to ajouter une retain. I want to answer the quote. I want to lower the yes. The graphs on vertical projectile motion. The graphs on vertical projectile motions. Here we are presented with what? With a straight line graph. Here, a straight line graph qui graphing, yeah, the velocity versus time. The velocity versus time. Good. Now, when I statement came over here, a boy stands at the edge of a high cliff. He throws a stone vertically upward with an initial velocity of 10 meters per second. The stone strikes the ground at a point below the cliff after 3.5 seconds. The velocity time graph below was obtained from measurements made during the motion of the stone. Again, so come on, let's say we've got a cliff. This will be our cliff. The stone is projected vertically upward and hits the surface there. Again, the total time of the entire motion of the ball, we are told that that stone, not ball, that stone took how much for the entire motion? It took 3.5 seconds. Again, and then the velocity at which it was projected is how much? It is 10 meters per second. Again, good. So now you are looking up as what? Up as positive and down as negative. So this is going to be positive what? Positive 10 meters per second. Again, that is good. Okay. Use the information on the graph to answer the following questions. Use the information on the graph. They are specific. Use the information on the graph to answer the following questions. Calculate the acceleration of the stone between t equals to 2 seconds and t equals to 3 seconds. And then how do we calculate acceleration from the velocity time graph? Gradient. Gradient you find? Gravitational acceleration. Meaning the gradient of the straight line will give us the gravitational acceleration. Here, we are given the time now. You know, Mama, 1 for 1.1. Here. So I'm going to tell from there. V at V2. Let's call it V2. If V2 are in here 2 seconds. What is the time at 2 seconds? Here. What is the velocity man at 2 seconds? At 2 seconds, velocity can negative 10 meters per second. Again. Good. Good. By kilo S1. Q negative 10 seconds. And then at 3 seconds. 3 seconds man. At 3 seconds. V3. After 3 seconds. What is the time at 3 seconds? Negative 20 meters per second. Are we together, good people? Yes. Good. So, good. It happens already. The direction tag. So, up will be positive, down will be negative. They are consistent with what they are having here. Again, graph a decrease. It's a decreasing function. Meaning gradient is negative. But if gradient is increase, graph in increase, meaning designing the downward into positive and upward negative, because function I want to increase. I want to guys. That's good. And then what is the time here? Time I'm gonna give time here 2 seconds here. Here the time is 3 seconds. So we're looking for the acceleration. Acceleration is going to be V3 minus V2 over T at 3 minus what? T at that 2 seconds there. Therefore V at 3 to okay, minus 20 minus into minus 10. Again, this negative gain formula, again, all over how much? 3 minus 2 by 1. Therefore, to a kind to negative 20 plus 10. Again, 3 minus 2 to get 1. Answer one negative 10. Why 1 and 2? It was meter per second square. I wanna. That will be our acceleration. Good. 1.2. Baba, at which time is the stone moving at a speed of 5 meters per second? Again, good people, they did not say the velocity. They said what? The speed. Why 1 and 2? Come on, someone. We know once the object is projected vertically upward, like this. Again, if you along its motion like that. Again, the speed. Polarity. 10 meters per second. 10 again. But if the velocity is in the opposite direction, but if there is speed, height to a speed at 10, if you have speed at 10, wow, height speed at 9, on a more speed at 9, height if a speed at 5, high along the way to speed at 5. Why 1 and 2? So, at which times is the stone moving at a speed of 5 meters per second? So in this case, let's check out positive, let's check out negative. Remember most speed limit LM5. Can I go most speed limit 5 meters per second? Demand is 0.5 seconds. And T is equals to how much? It's okay? 1.5 and minus 5 at 1.5 seconds. So these are the times where speed is how much? Where speed is 5 meters per second. Are we together with people? Good. 1.3. For 1.3, after how many seconds does the stone reach its highest point? Its highest point. How do we get the maximum point? How do you see the maximum point from the velocity time graph? Here. Très bon agent. Très bon agent. Kana, what do we know about the maximum point? What do you know about the maximum point? Velocity equals to 0 meters per second. So graph when you want to take more velocity in 0 meters per second. 1 second. So it's only the x-intercept. So more than the x in time. So whenever the graph cuts the x-intercept, when it cuts the x-intercept, the maximum point, because velocity is 0. So at which time? What time is that? After 1 second. After 1 second. And then 1.4, Babare, determine the height of the cliff from which the stone was thrown. The height of the cliff from which the stone was thrown. Again. Good. So kita kenali A. Kita kenali A, B, C, D. Ayer. A, B represents the maximum height above the cliff. Ayer. B, D represents the height above the maximum height above the ground. Ayer. So from our graph, our graph is like this. So mona keep 5. Is it 5? 10. Keep 10 a year. Mona we have 1 a year. And then 1 minus 10 okay. What is the time at minus 10? Key 2 a year. Mona key 2, mona we minus 10 a year. And then money who what I'm fast keep 3.5 seconds somewhere. Ayer. So Rari, come on, A, Kimo, initial point. B is the maximum height there. Ayer. Where is the ground? It over A, it over D. Mo, yes. What is the velocity at D? It's what? Negative? It's negative 25. Ayer. Now, how are we going to get this height? We are looking for this. How do we get this? Hearing BD, this height, BD, minus which one? Minus AB. Then we'll be left with this part here. This part CD will be what? Will be the height of the cliff. Yes. AB, that will be the smaller triangle, this one. Because we're moving from A to B. A to B, this triangle. Again. And then B, D, B, D, that is the what? That is the bigger triangle. Are we together, good people? Yes. So in order for us to get CD, the bigger triangle minus the smaller triangle, then we'll get what? CD. So the bigger triangle minus the smaller triangle. So the height of the cliff, it was half base height, a small of the big triangle here, minus half base height of what? Of the smaller triangle here. So this is going to be what? This is going to be 1/2. What is the base of the big? Is 3.5 minus 1. That is the base again. So it's over 3.5 minus 1. What is the height? Moving from there to here, we're going to use 25. Why KBL positive 25? Because we are height. Height is it's a scalar quantity, another direction here. So 25, you have a minus 1/2. What is the base of the smaller triangle? 1. So 0 or 1. What is the height? Go to a more. Keep 10. Keep 10. Can you see that? Good. Please punch this on your calculators. So it over. It's about 26.25. 26.25 meters. This is going to be the height of the cliff. Are we together, good people? Yes. Now you can use this. Have it without using the equations of motion. Why am I doing it now? It's because this is what we're doing over the weekend again. So now I'm going to do another option. Because in this case they were not specific on what to use. They just said calculate the height of the cliff. What do we know, guys? We know that VI is what? Is 10 meters per second. Ne? The time it took to reach the ground is how much? Is 3.5 seconds. Are we together? And we know the acceleration. How much is the acceleration?
9.
Keep going.
9.
Then it becomes very wrong. Why can't we use 9.8 meters per second squared? Because we calculated the acceleration. Why what? We calculated the acceleration for that motion. It's like minus 10. Then we can use the equations of motions to find what? Changing what? The height. Then. So, okay, with our data, what do we have? We've got VI, which is what? 10 meter per second. Acceleration, we got it as minus 10 meter per second. Isn't it? What else do we have? The time. They said it took how much? 3.5 seconds to reach the ground. Again. Now we got what? Changing 1. How can I motion 1 to here? I get it again. Projectile on again. I said we always take what? The initial position of the ball as the 0 reference point. Again. How can I here? Well, it was most. Don't lose to a mon. Sayodimu. Again. Say that. Sahud. Has to put a monas to you. What is the displacement of that stone at this position? At C, A, B, C. At C, is 0. And then that stone, basically, la pelissa party hit the ground there. Are we together? So, this displacement, is going to more, it will be the height of the cliff. The height of the cliff. So formula na lento tena ka ofela ke changing y ne. Here na changing y is equals to vi changing t plus 1 over 2 g changing t squared. So this is going to be vi is how much? 10 multiplied by 3.5 plus 1 over 2 negative 10 and what here? 3.5 squared. Yes, can you please find that on your calculator? Hello. And how much did you get? Negative 26.25 meters a year. What is this? This is no. This was the displacement of the ball a year, which is 26.25 meter downward a year. But now, what are we looking for? The height of the cliff a year. The displacement of the ball is to a monana who's 0. You put a who's 0. If you displacement thing, it was more means the displacement of the ball is equal to what? The height of the cliff. So now the height of the cliff, you're going to have 26.25 meters. So man, how do you look at how do you look at 9.8 scout lot? How do you calculate man acceleration? Yes. It's important to open once again both methods. Because sometimes they will say without using the equations of motions. Any questions, guys, so far? So far, so good. Good. Now, what is the next question? It's 1.5. Using the top of the cliff as the initial position of the stone. Sketch the position time graph, displacement time graph for the motion of the stone from its highest point until it reaches the ground. Only indicate relevant time values on the x-axis. So this is what we're gonna do for this part. Now, remember, So what we're gonna do is just start. A. What is the time at A? 0. Is 0. What is the displacement? Because we are doing time against what? Displacement. There. What is the displacement at A? There. What is the displacement at A? 0. B. The maximum height. What is the time at the maximum height? 1. Recalculate the maximum height. Maximum height recalculated? No, we didn't calculate the maximum height. But we can get the maximum height. This area there. This area from A to B. From A to B there. On a la série chapelle la mona here. Comment on a the maximum height? You can lay 1 over 2. You can 1 times what? 10. So the maximum height is 5 meters. So that will be how much? 5. Come on, and then at C. What is the time at C? T2. Because if it takes 1 second from here to there, it will take 1 second from there to here. So the time is 2. What is the displacement at C? At C, point C. Point C, A, B, C. 0. And then at D. What is the time? 3,5 seconds there. Now what is the displacement now at D? Negative 25. Displacement. Because keep on here. Put a motor man. Negative 26, negative 26,25. Say everyone learn? Yes. Good. And now, Berlin. Grade 1. 0, 5, 10, 15. 5, 10, 15, 20, 25, 30. You are going to use your ruler here. Yes. 20, 25, 30. Negative. And then 5, 10, 15. We write what here? Displacement. In meters, here you write what? Time. In what? In seconds. 1, 2, 3, 4. Moneta about 3.5. Good. Now we plot our graph using our points. That A, B, C. Now it's over 0 to 0 time is 0. 1 is a 1 is a 5. Here. And then 2 is a 2 is a 0. And then 3,5 is a the negative 26. Negative 26, it's somewhere there. Here. This will be our point. And then we sketch our graph. We follow them. This is the position versus time graph of the stone that was thrown from the top of the cliff until it hits the ground. But now the instruction was taking what? Taking the maximum point as the initial position. So comment on retrouve ça bon. Comment on stone nous sort Stanley mot ça y est de la partie. You get that? Yes, it was that one. They said using top of the cliff as the initial position of the stone, sketch the position time graph for the motion of the stone from its highest point until it reaches the ground. Its highest point in the look at 1 second from here until it reaches the ground. This is how your graph should look like. Are we together with people? Yes. Questions? Something that you did not understand here? Zamonat. Kofela. Sonanzi. Asibonke ke kopa re ntshe ntho eno ho thwe ke pampiritsane tse ding tsa bobedi tsane re ngole question ya pele re kgone ho e tshwaya ka tlase. Thank you.